Good morning, my YouTube viewers. Crystal here. I'm here this morning because I wanted to make you another video. Unfortunately, it's the middle of the night, so I had to turn my camera off. I found out that it just works a lot better for me if I, get some sleep and some rest and then I make a video, because obviously it's not good for me and it's not good for you for me to make a video when I'm really tired. So if I've got some sleep, then I can make a video and it'll turn out a lot better because I won't be so tired when I'm making it. And what I wanted to do was I wanted to make you a video on the breast cancer data set that's actually loaded up in the sklearn library. And so that's what we're going to do, is we're going to go over that. That's the last toy data set that sklearn has already installed in their library. So you won't be getting any more videos from me on their toy data sets unless they install a data set. Now these data sets are already installed on the sklearn library, so you can use them to conduct experiments. So you don't have to go out looking for data sets. They're already in the library. So what I did on this data set was I created the data set in Google Colab, which is a free online Jupyter notebook. It's got Python and a lot of the libraries already installed on it. But unfortunately, what I found out recently was that it doesn't have the most current libraries on it, which can be a little bit exasperating. And it's actually true in this case, because I could have used a function called sframe, but because Python does not have the most current version of sklearn installed on it, it doesn't have that sframe function that I could use. So what I'm having to use is return xy. But when it gets Google Colab gets the most current version of sklearn installed on it, then what I'll do is I'll do a video on sframe and show you how to use sframe. So we got this data set. It's a Wisconsin data set, and you can see that it's a copy of the UCI data set. UCI stands for University of California, and I is an initial of the city that it's in, but I don't remember the name of the city. Sorry. But I went actually to conduct this research. I clicked onto this link here, and if you click onto the link, then it will actually take you to the UCI program where you can download the data set. And I tried to download the data set on my computer, but it didn't have all 30 columns for the x variable. It only had about 10 columns. So although the citation on sklearn says it's a copy of the UCI ML breast cancer Wisconsin diagnostic data sets, it's got a lot of extra information on it, because this data set in sklearn has 30 columns, whereas the breast cancer Wisconsin data set only has about 10 columns. And because of that, because there's a disparity between the number of columns in sklearn's data set and the number of columns in the Wisconsin breast cancer data set, the UCI version, I just decided that I couldn't do a legitimate video on that particular data set and compare the two, since there's such a disparity. And the other information about this data set is features are computed from a digitized image of a fine needle aspiration of a breast mass. they describe characteristics of the cell nuclei present in the image. So that's the information that we get on this data set. So I will be doing a video on the breast cancer Wisconsin data set, but I'll have to explain that it doesn't appear to be the same data set that was on the SK-Learn's data set. And then so hopefully that will give us a little bit more clarity. So after I created this program in Google Colab, once I completed the program, I clicked on to download IPYNB, and that put a file in my download folder in my computer. And then whenever I downloaded it, I was able to save the copy of the program into my GitHub account. So what you're looking at now is my personal GitHub account. And what I will do is I will make a blog post on this data set. And when I make the blog post on this data set, I will give a link to my personal GitHub account so you can copy the program if you want to. One thing I did yesterday is I was looking up, how to win a competition, because that's what we all want to do. We all want to win competitions. Well, people who win competitions are not going to give their code away because it helped them win a competition. And then if you can actually win a competition, then what will happen will be, you'll be subject, open yourself up to a lot of job opportunities. And so they're not going to give the code away for the competition. And they said that normally the code is generally a mess because in order to win the competition, they have bits of code everywhere. But I would like to win the competition. And, I'm working on data science and I'm working on improving my skills. And then whenever I improve my skills, who knows, maybe I will win a competition at some point. But people who win competitions don't give their code away because it's like a trade secret. So what I'm giving you isn't a trade secret. It's just a standard way to make a program, and it doesn't have anything fancy in it. So now that you know what I did yesterday, trying to find out how to win competitions, and I wasn't very successful at it because nobody's willing to share their trade secret with me, we will carry on with this video on how I created the program and what was the outcome of the program. So the first thing that I did was I imported the libraries. These are Python libraries, NumPy, Pandas, Matplotlib, and Seaborn. Now these are just some of the libraries that we will need to execute this program. NumPy is a mathematical algebraic library that allows you to carry out algebraic functions. Pandas is a library written on the back of NumPy, and it allows you to work with data frames. Matplotlib is a graphical library that allows you to make graphs, and Seaborn is also a graphical library, and it is written on the back of Matplotlib. So we just installed 4 of those libraries that we know we're going to need to carry out this program. But it's not all the libraries that we're going to need, that I would like to state that. So the next thing that we did is we imported our files. The nice thing is you don't have to go out looking for a data set to use. This data set is already in the sklearn library. If you want to know what data sets sklearn has, then you just need to look up toy data sets. And under toy data sets, they have several data sets that are already loaded into the system. so you don't have to go out looking for a data set, and you can use these data sets to experiment. The downside of the data sets that are loaded into the sklearn library are the fact that some of them are already standardized, and if they're already standardized, it's going to be a little bit difficult to conduct an analysis, which is what I have found in this particular data set. But I went ahead and analyzed it to the best of my ability, even though the information has already been standardized. So you type in from sklearn datasets, import load breast cancer, and XY equals load breast cancer, return XY equals true. So that's an older command, an older parameter. Now, what you could do is if you had the most current version of sklearn, you could have put in the attribute as frame, and then if you put in the attribute as frame, then it would have returned it as a data frame. But since Google Colab does not have the most current version of sklearn, I couldn't do that. But what I might do is I might, when they get AskFrame working on Google Colab, I might do a video on AskFrame just to show you how to use AskFrame. So, but we didn't have AskFrame in this instance. We just had return XY. So we did X shape, which is 569 rows by 30 columns. And so you can see X here. It's an array, and it's already been standardized. So what I did was I created a data frame because we're going to need the data frame. So I did df underscore x equals pd data frame x. So now we've got a data frame of all of this information that, in a way, it looks to me like it's already been standardized to me. You've got column 0, column 1, column 2, column 3, column 4. It looks quite, it looks to me like it's been standardized. A lot of it looks to me like it's been standardized. Maybe column 0 isn't standardized. Column 1 isn't standardized. Column 2 isn't standardized. Column 3 isn't standardized. But 4 all the way to 29 definitely looks standardized to me. And now we want to look at our y variable, and y is a series of ones and zeros. Now I'm just going to work on the assumption that 0 means it's non-malignant or benign, and 1 means it's malignant. I'm going to work on that premise because they really don't even tell you what a 0 or a 1 is, so we're just going to have to take an educated guess. So now what we want to do is we're going to use seedporn, and we're going to create a disk plot of y, so you can see that there are less zeros than there are ones. So what they did was they did an aspiration of an existing tumor, and when they did the aspiration of the existing tumor, they took all of these tests on it, and then they said whether it was benign or malignant. So I'm just going to take an educated guess, and I'm going to say that 0 is benign and 1 is malignant, since it's a breast cancer data set. So now what we did was we took y and we converted it to a data frame by doing df underscore y equals pd data frame y. So now you've got a data frame for x and a data frame for y, but they're not called x and y, they're called dfx and dfy. Because the reason we did that is because we need to perform an analysis of this. So cancer equals dfy value counts. So 1 is 357 and 0 is 212. And percent cancer is DFY, value counts, over, divided into length of Y. So you've got 1 is 62.74%, and 0 is 37.26%. Now what we've done is we've done a heat map of all of the independent variables, which is our 30 columns. Now what we want to do is we just want to make a 2D diagram of this. So we get the mean of X and the standard deviation of X. The mean of X is 61.89 and the standard deviation is 228.29. And then what we're going to do is we're going to do something called feature columns equals feature plus string I for I in range X, shape 1. And now we're going to normalize that information. So normalize equals PD data frame X columns equals feature columns. So you've got 30 columns, and this information is normalized information. Now what we got is now what we're going to do is we're going to create a 2D graph with this information, with this normalized information. So from sklearn decomposition, import PCA, that's principal component analysis. PCA cancer equals PCA in components equals 2, because you only want to use 2 of the columns because it's going to be a 2-dimensional diagram. Principal component cancer equals PCA cancer fit transform X. And then so we get our 2 columns, principal component 1 and principal component 2. And then we get our explain variation per principal component, and you get that information. And now what we do is we use code to make a 2D diagram. And so I'm going to say 0 is benign, 1 is malignant. So you can see that there's lots of zeros in there with the 1s, and the 1s are all clumped together, but there's lots of zeros out there, and there's also a few outliers. And that means it's going to be more difficult to perform an accurate prediction on this information because you've got zeros mixed in with 1s. So it's going to be a little bit more difficult for the computer to determine if something is a 0 or a 1. So now once we have done that, once we have created our 2D diagram so you can look and see where the zeros or 1s are fitted in the computer's memory, what we want to do is we want to split X. So we split X into training and validation shapes. And then what we've done is we decided we're going to create our model. And when we created our model, we decided we were going to use Nearest Neighbours. So the last video I made, I used radius neighbors, but I decided that on this video, I was going to use K neighbors classifier just to see if it works better, see what I get on K neighbors. So I had in neighbors equals 12, weights equals distance, and I got 100% accuracy when I trained and fitted the data. When I predicted on the validation set, I only got 98% accuracy. I created a confusion matrix, and so on the zeros, we've got 1 that was a 0 that we said was a 1. So there was only 1 error when we carried out this, executed this problem. But I'm going to go, when I finish this program, I'm going to go do a little bit more information and see if I can get the information to 100%. That would be great, don't you think? And now what we've done is we've created a data frame with the actual values and the predicted values, so you can look and see that there should be, if you go in there and look, there should be one of them that's not correct. And I'm just doing a quick visual inspection here to see if I can find the one that's not correct. There is one that actually isn't correct, and it's number 38 isn't correct. And then after we've done that, then what we've done is we've done a 2D diagram to plot the errors. So there should be one little 0 dot in there to indicate that there's one error, but I don't particularly see the 0 dot, but there is one error, but unfortunately it hasn't showed up on the 2D diagram. So that concludes it for this video. We've taken the data set, the Wisconsin breast cancer data set from sklearn, and we have used that to create a program to predict upon it. And we had a 98% accuracy, which isn't bad, but I'm going to go back and do some more work on it to see if I can get it up to 100% accuracy, because that would be really great if we can get it up to 100% accuracy. So if you like my video, please like, subscribe, and share. If you want to receive a notification of whenever I make a video, then please tap the bell button next to the subscribe button, and you will be notified whenever I make a video. And if you like the work I do and you want to support me, I've got my email address to my PayPal account, because I'm not allowed, I don't have enough subscribers, so I can't monetize. And thank you so much for watching this video. I look forward to making more videos for you in the future, and I hope you have a very nice day.